Okay, so product of a unit fraction, a whole number. Product means multiplication. So that means we're going to do 1/3 times 27. So we're multiplying them. But we've seen how to multiply fractions. But how do you multiply a fraction with something that's not a fraction? Well, you can put a 1 underneath anything because, well, 27 divided by 1 is still just 27. Okay. So then we can say, oh yeah, 1 times 27 is 27 on top. 3 times 1 is 3 on the bottom. Okay. But remember, a fraction is always just division in disguise. This guy right here means 27 divided by 3. Well, 27 divided by 3 is just 9. And we get that. And that's basically how it's done. So you're just going to, on this topic, you just slap a 1 underneath the whole number, like we did here, and then you can just multiply like normal. And then, do any simplifying that's possible, like we did to get the 9. This topic is more of the same stuff. So I'm going to slap a 1 underneath there, and I'm going to multiply again. Okay. 3 times 32 is 96, and 8 times 1 is 8. And let's see, does anything divide into both of them? Well, certainly they're both divisible by 2. Okay. So then that would be 48, I think, over 4. And then you might remember, oh yeah, 48 divided by 4, that's 12. Okay, and that simplifies. Or you could, cancel, divide more stuff out like that. Or maybe you remember your times tables and you say, oh yeah, 96 divided by 8 is 12, and you just jump straight to the 12. So the better you are with your times tables, the easier this is going to be. Okay, now let me show you something else that you can do. Okay, and this only works when it's multiplication. Okay, so here, I'm just going to write the problem bigger, and then I don't know, I'll just like it better. Okay, so there's the problem. Now, if this is division, addition, or subtraction, it's not going to work. It has to be multiplication. You can basically just say, well, is there something that divides into any number on top and at the same time any number on the bottom? I could say, well, I know that 8 divides into this bottom number and this top number. It has to be a bottom and a top and a bottom. Yeah, 8 divides into this guy once, and 8 divides into this guy 4 times. And then you can say, all right, 3 times 4 gives us 12 on top. 1 times 1 gives us 1 on the bottom, and that's just 12. So you can think of it that way if you like. The advantage of doing that is you start trying to simplify things before the numbers get really big, like that 96. And it's like, okay, this is a lot bigger. I'm not as sure what divides into that. But when the numbers are smaller, like 3, 8, 32, and 1, it's easier to see what divides in. So either way is fine. Okay. Okay, so here we are. We're doing more fractions, except this time you don't have to put the 1 underneath anything. Not that that was, particularly challenging or onerous. Okay, so again, I could just say 2 times 9 is 18. 3 times 8 is 24. And then I could say, oh, wait, but 6 divides into 18 and 24. It has to be the same number right there. Okay, if they're different numbers, then it's not going to work. Okay, 18 divided by 6 is 3. 24 divided by 6 is 4. And that's as far as it's going to go. These guys have no common factors. So 3/4 is our answer. Or, like I said on the last one, you could say, hey, is there some number that divides into one of the top numbers and one of the bottom numbers? Yeah, 2 is going to divide into both of them. So I could say 2 divides into that once, and 2 divides into 8 4 times. Okay. And then I could say, hey, 3 divides into both of these guys. Again, a top number and a bottom number. Excuse me. So 3 divides into 3 once, 3 divides into 9 3 times, and we could just jump to the answer, but let me simplify what we got here. So we've got 1 over 1 right now, and in the second fraction, we have 3 over 4. And now that we multiply, we've got 1 times 3 over 1 times 4 is 3/4. Okay. And again, either way is fine with me. You can simplify at the beginning or at the end. I like doing it at the beginning, but both ways are going to work every time. Okay. So here's another, it's just more practice. It's like what you've been doing already, but it's, it's good to have the practice. So I see a fraction multiplied by a non-fraction. So I slip the 1 underneath. And then I say 4 times 8 is 32. And 5 times 1 is 5. Okay. Okay, so on this one, now we got 3 fractions. Well, who cares? It just means 4 times 5 times 3. Let's see, that's going to be 20 times 3 is 60. And then 7 times 3 times 4 would be 21 times 4 is, what is that? 21 times 4, 84, I think. Oh, I sure hope I'm doing this right. Okay, so then I could say, hey, what divides into 1684? I don't know, but 2 certainly does. I mean, they're both even, so I'll divide 2 into both, and I'll get 30 over 42, I guess. And oh, look at that. They're both even. 2 divides into both. Oh, and 3 plus 0 is 3, which 3 divides into that. 4 plus 2 is 6. 3 divides into that. So 3 also divides into both of them. So 3 divides in and 2 divides in. So I guess 6 is going to divide in. Okay, well, let's do 6. 6 divides into 30 5 times, and 6 divides into 42 7 times. Or you could have done 2 and then 3 separately. Or maybe right at the beginning, you notice, hey, 12 divides into both of those. And then just jump to there and only do one simplification. So 5/7 is our answer. Now, once again, we could have just said, all right, we can cancel stuff, simplifying as we go before we do the multiplication. Any top with any bottom. Well, obviously, 4 divides into both of these guys. 4 divides in once, 4 divides in once. And 3 is going to divide into both of these guys once each. So that we get 1 times 5 times 1 is 5. 7 times 1 times 1 is 7. So, I mean, you don't have to do it multiple ways, but I am trying to give you multiple options so that you can pick what works better for you. All right, so now we're going to start tinkering with negative signs. Well, guess what? There's nothing new here. Remember, we've already seen that when you are multiplying or dividing, if the signs are the same, you get a positive. And if the signs are different, you get a negative. Again, for multiplication and division. Well, I'm multiplying a couple of negative numbers, so my answer is going to be positive. So, okay, so my answer is positive, which means now I don't have to worry anymore about these signs. So just figure out the sign of your answer, and then you can ignore the signs. I've got a fraction times a non-fraction, so I'll slip a 1 under there, and I'll say 6 times 7 is 42, and then 1 times 2 is 2, and 42 divided by 2 is 21. So just figure out the sign right up front. Is it a positive or negative? And then just ignore it and do what we've been doing in this video. Okay, let's do just one more of those. Hey, look, I've got a positive times a negative. The signs are different with multiplication, so my answer is negative. There, I can now ignore the negative sign. All right, so I put a 1 under there. I notice that 4 divides into that top number and that bottom number, and I can cancel a 4 or divide it away because it's multiplication in between. So 4 divides in once, 4 divides in twice, and I get 2 times 7 is 14, and 1 times 1 is 1, or just negative 14. And there you go. Not really, too terribly crazy. Oh, good, it's a word problem. Okay, so I love word problems. You can absolutely expect some of those on tests. Okay, Kala. Kala. Wasn't that the name of Tarzan's adopted mom who was an ape? I think it was Kala. Okay, Kala had 6/7 of a spool of yarn. She used 2/5 of her yarn for a project. What fraction of the spool was used for the project? Okay, so I think we can all agree that an alternative way of asking that question is like this. Okay, 2/5 of 6/7 is how much she used. Okay. I'm assuming Kala's a woman, but oh yeah, it says she. Okay. All righty. So that would be, another way of doing it. So, well, the word of in algebra means multiplication. So this just means 2/5 times 6/7. You'll notice there are no top numbers that have a common factor with a bottom, so there's nothing to cancel up front. So 2 times 6 is 12, and 5 times 7 is 35, and so 12/35. Okay, so just think about how you would phrase it out loud. You say, yeah, 2/5 of her 6/7, that's what she's using. That of, though, means multiplication. Okay. Now, sometimes of just means of. But here, it means multiplication. And in math problems, that's often what it means. So that is definitely something, that you want to be thinking about. Okay, so now we're on mixed number multiplication. So we have a mixed number here that we're going to multiply by some fraction. Okay, well, let's face it. If this was just a fraction and there was no number out in front, we'd be in great shape. Now, there's different ways you can handle this, but here's the way I'm going to do it. I'm going to say, let's use an idea that we've seen in the past, not too far back. And then once we use that idea, well, we're home free. Here's what I mean. Let's rewrite this guy as an improper fraction so that there's no number out in front. So remember, we do 5 times 2 is 10, plus 2 is 12, and so that's just 12/5. Well, we're home free now. Yeah, we can say, we know how to handle this. 12 times 2 is 24. 5 times 3 is 15. But 3 divides into both. And I could have taken care of that at the beginning. I could have said, well, 3 divides in once and 4 times, but I didn't bother. So 24 divided by 3 is 8. 15 divided by 3 is 5. And we get 8/5. Okay. Now, it does say write your answer as a mixed number in simplest form. Now, we just took care of the simplest form with that, canceling a 3, dividing a 3 away. But we still got to do a mixed number. Well, we know how to do that. You just say, well, first of all, the denominator will not change. So we say 5 divides into 8 how many times? Once, with a remainder of 3. And we've done that in the past. So that's all you do. So you just take the mixed number, write it as an improper fraction, and then you can just do your regular multiplication like we've been doing in this video. And then, where appropriate, where necessary, write it as a mixed number, when the numerator is bigger than the denominator or equal. All right, so this is, we already have seen enough that I bet you can figure this out without me. In fact, if you want to pause the video and do it on your own, that's probably a great idea. Okay, I'm assuming you paused it. So we could rewrite 3 and 5/6 as, an improper fraction like we just did. So 6 times 3 is 18, plus 5 is 23. And of course, the denominator doesn't change. And the 9, well, we could say we just slap a 1 underneath it, and it's just like what we've been doing. So we notice that 3 divides into 6 and 9. So I'm just going to take care of that now instead of later. So 3 divides in twice, and 3 divides in 3 times. So we get 3 times 23 is 69, over 1 times 2 is 2. And 2 divides in 34 times with a remainder of 1. And that's how we do it. So it's just putting together all these different concepts that you've already learned. Okay, so now it's time to see exponents again. So again, this 3 right here means we're going to take 2/3 and multiply it by itself 3 times. Okay? And now you can just say, oh, well, we actually did a topic just like this, multiple fractions multiplied together. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, and we're done. So one way to do it is just write it out as a multiplication. Another way to do it, and this will be good for you to see whether you do it this way immediately or not, is to say, is to use a rule of exponents, and that is, when you have a fraction raised to a power, that means that everything inside the parentheses is being hit by that exponent. So I could say, well, I'm going to hit the 2 with an exponent of 3, and I'm going to hit this bottom 3 with an exponent of 3. And 2 to the 3rd power is 8, because it's just 2 times 2 times 2. And 3 to the 3rd power is 27, because it's just 3 times 3 times 3. And you can think of it that way. And both ways are good. If this number starts getting big, well, this way down here is going to become more and more desirable, because, if this was instead of a 3, if it was a 10, you got to write the fraction out 10 times. And that might not be fun for you. Okay, these last 3 topics are about parallelograms and fractions. I don't know if you can hear. I got a little space heater on, a little heater fan. Oh, I'm told you can't hear it. It doesn't. The microphone doesn't pick it up, but hopefully you don't. But my feet are freezing. Okay. Anyway, so I will focus on the math. Find the area of the following square. All right. So every shape, like square, rectangle, circle, they all have their own formula for the area and for other things like perimeter. Well, the area of a square is just going to be, so area is going to equal the length of one of the sides times the length of one of the sides squared. I mean, after all, a square is just a special rectangle where all sides are the same length. Well, if it were just a regular old rectangle like that, and we said, well, this is the base, this is the height, you've probably heard that the area of a rectangle is base multiplied by height. So the area of a square would be, let's see, if this is the base, then the height would be the same thing, because all sides are the same length in a square. Then we would just say, oh, so the area of a square is the base multiplied by the height. But that's just s squared. Hence, that's where the name of this shape that's where it gets its name, from the formula for the area, s squared. Anyway, all right, so be that as it may, the point is, to get the area, we will take all sides, all 4 sides are going to be 2/3 of a millimeter. And so you would do the base of 2/3 multiplied by the height of 2/3, or in other words, 2/3 squared. You can write it like that or that, doesn't matter. And that'll give us 4/9. And again, this formula that I'm using, it's only for squares. That's it. For rectangles, well, you know, the base and the height, they're going to be different lengths. And therefore, I need to use a different formula, okay, because it is a different shape. Okay. So on this one, find the area of the rectangle. So now we have a rectangle, not a square. And like we just saw, the formula is going to be the base, which is, well, the same as this side here, 2 1/4. So the base multiplied by the height, which is 7/12. But, spaghetti-o, I see a mixed number. I think I know how to handle that. 4 times 2 is 8, plus 1 is 9. So this is 9/4 times 7/4. Or no, not 2/4, 12ths. Oh, and on that last one, it was supposed to be, let's see, it was 4/9, I think. I didn't include my units. It was square millimeters on that last one. I apologize for that. Yeah, always think about your units, always include them. Okay, and they ask you to include them. When we talk about area, like we did on the last one, this one, and the next one, area is always square units. Square millimeters, square inches, square meters, square miles, square light years, square, 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 E-I-E-I-O. Okay, so on this problem down here, though, I notice, hey, I could cancel a 3 divides in 3 times, and 3 divides in 4 times. So 3 times 7 is 21, and 4 times 4 is 16. And let's see, write your answer in simplest form. Okay, so people are probably not going to want you to say 21/16 square yards. They're going to want something like this as a mixed number. So 16 divides into 21 once, with a remainder of 5. And because we're working with yards, I put yards, and because it's area, it's square yards. Okay. All righty. And that's how you do it. Again, it's using things we've already seen. Oh, I have a mixed number multiplied by a fraction. I need to convert that into an improper fraction. Now I can do the multiplication. I also see the simplifying of, with the getting rid of those factors of 3 there, and then turning it back into a mixed number, and blah, blah, blah. So yeah, that's how it's done. Okay, now we're still working with area. So that should tell us that out of these 3 choices, as part of our answer, we should be going with square yards, because that means area. All right. So it turns out that to find the area of a parallelogram, and a parallelogram is just a rectangle that is leaning to one side. Okay, but a parallelogram has, like a rectangle, opposite sides are parallel. So those 2 are parallel, and those 2 are parallel. But you don't have to have 90-degree angles, like on the corners. The corners are, well, in fact, they're not 90s. Okay, and there's other things we could say about this, and I could explain where this formula comes from, but it turns out that the area of a parallelogram is the same as the area of a rectangle. Base times height. Okay, the base is 15. Oh my goodness, look at this. There's no fractions. So 15 yards times, now, is the height 10 or 8? The height is always the straight up and down distance. So we don't even need the 10 for this problem unless we wanted to find the perimeter, which, well, we're not doing. So 8 is going to be it. So we want that straight up and down, not this slanted thing here. We don't want the slant for the height. And then 15 times 8 is 120. And just to kind of get you thinking about it, yards times yards is, well, when you multiply something by itself, it's that thing squared. That's where the squared is coming from. That's where the yard squared or square units are coming from for area. Anyway, that's how you do parallelogram. You basically do it just like the rectangle, which is really cool.